At 27 degrees Celsius temperature in 1 liter container, if gas is passed over 6 gram of activated charcoal, then the pressure of the gas decreases from 700 to 400 millimeter of mercury. Calculate the volume of the gas. Density of charcoal is given. So the options given are the P1, that's 700 millimeter of mercury. We can convert it into atmosphere by dividing it by 760, so that you're going to get it in terms of atmosphere. And the P2, the final pressure, that's 400 over 760. This is going to give you in terms of atmosphere. And the volume of the container is given, that's the initial volume, that's 1 liter. And the mass of charcoal is given, that's 6 gram. The density of charcoal is given 1.5 gram per cm cube. So now you have to find out the initial number of moles and the final number of moles here. N1, we know that PV is equal to nRT, where R is the gas constant and whose value is 0.0821 liter atmosphere per mole per Kelvin. So if you are going to substitute that initial number of moles, N1 is equal to P1V1 over RT1. So here it is 700 over 760. Initial volume is 1 liter over R is 0.0821 times T. The temperature is given 27 degrees Celsius. That becomes 300 Kelvin. So if you substitute this, you are going to get 0.0374 mole. This is the initial number of moles. Since you are provided with the mass and the density just for charcoal, you can find out its volume. We know density is equal to mass by volume. So the volume occupied is equal to mass, that's 6 over 1.5. That is going to give you 4 cm cube. So out of 1 liter, you have the initial volume as 1 liter, out of which 4 cm cube has occupied by the charcoal. What is the remaining volume? That's 1 minus, or if you convert it into cm cube, 1000 minus 4. That is 996 cm cube. Or 0.996 liter. You can apply this in the formula N2. The N2 is equal to P2, that's 400 over 760 into, now the volume has become 0.996 because some of the volume is occupied by the charcoal, and 0.0821 times 300, that is going to give you the value of 0.0213 mole. So what is the number of moles of gas adsorbed? That's this minus this. The final initial volume, initial number of moles minus final number of moles. That's going to give you 0.161. This many moles. So you know the number of moles. This is adsorbed by 6 gram of charcoal. So if that is the case, 1 gram of charcoal is going to adsorb how much? That's 0.0161 over 6 is going to give you the mass adsorbed by 1 gram of charcoal, and the volume adsorbed at normal temperature and pressure is given by volume adsorbed is equal to this volume multiplied by 22,400. So this is going to give you around 60.2 or 60.1 cm cube, or the option is 60 ml.